Okay, Algebra 2, as you know, I've made two separate videos about Chapter 2.3. Chapter 2.3 is all about how to draw graphs quickly when you have a linear equation. And the separate video was for these first two steps with the discussion about slope-intercept. This video is going to focus on the other kind of form that is discussed in Chapter 2.3, which is the standard form of a linear equation. So before I go any farther, I just want to pick up where we left off from the last video, and this is also something we talked about quickly in class. Here's a word problem that is representative of a slope-intercept situation, and here's how you know. First of all, a typical tip-off word that you've got a slope, a rate of change, in other words, is this word right here, per. Now that doesn't mean every time you see the word per in a word problem that you've got a slope-intercept situation. I'm just saying that it can be a tip-off word, so don't automatically jump to conclusions, but in this case you do, because you've got a rate of change, and that rate of change is 4.6 million hectares per year. And you also have a starting place. That starting place, remember, is going to be your y-intercept, and that starting place is the amount 718.3 million hectares back in 1990. So your starting place was 718, and then you're changing downward, you're declining by 4.6 million per year. By contrast, here's a standard form situation. Here's a word problem, or here's a real life situation where you could set things up more easily in a standard form style. In this case, what you have is a goal, $1,200, and you've got two things that are going to lead you toward your goal. One is the profit from each sweatshirt, and the other is the profit from each t-shirt. And each of these has a coefficient associated with it, $2.50 each for the sweatshirt, and that each is a key word, and $1.50 each for the t-shirt. These words, these each words in each place, are telling you that you're going to multiply $2.50 times a variable, or $1.50 times a variable. And the variable is how many you sell. You don't know how many t-shirts you're going to sell. You don't know how many sweatshirts you're going to sell. But in this case, combine the two, and you're going to add up, you hope, toward your goal. You're not going to reach your goal without. So when they ask you to describe the number of sweatshirts and t-shirts you can sell to reach your goal, your first step is to set up an equation. So what does a standard form equation look like? It looks like this. Very simply, 250 times S, or in other words, 250 times all the sweatshirts, plus 150 times all the t-shirts is going to equal $1,200. So as I said at the beginning of this short video, one of the goals of the video is for you to be able to, and one of the goals of the lesson is for you to be able to find a standard form equation within a word problem, within a real life situation. So let's practice that. Here's your turn to identify that standard form equation out of this word problem. Hit the pause button, and when you're ready, come back and I'll show you the answer. Okay, I'm going to assume that you did that, and here's the answer that I was looking for. 0.10, you could have said 0.1, times all the dimes, in other words 10 cents for every dime, plus 0.25, or in other words 25 cents for every quarter. Collectively, those are going to equal your goal of $50. If you're not seeing how to turn this story into that equation, come and ask me, and I'll give you some more sample problems. I'll help you work through a few, and I'll give you more that you can do. But the next objective is to be able to turn these into a graph. So I'm going to go back. Remember, we said this was our standard form equation for the sweatshirt t-shirt story. How would we graph that? So here's that same equation. Well, first of all, let's not call them X and Y. Let's call them S and T for sweatshirts and t-shirts. It doesn't matter which one you plot as S and which one you plot as T in this case, because this is not one of those dependent-independent variable situations. It's not as though one of these is the driver for the other or vice versa. They're both equal contributors to your goal. So I'm going to, in fact, suggest that you move those right over the S and the T, I mean the X and the Y. And then, speaking of move right over, the way to graph it is what I call the cover-up method. And follow along with me if you would, because here's how I do it. I literally cover up one of the two variables, including its coefficient. What I'm saying is, what would happen if there weren't any t-shirts sold? What would happen if I only sold sweatshirts? Well, in this case, I've got 2.5s equals the 1200. And in that case, my t value here is going to be 0. So what I'm going to have is an s-intercept. Now, you get rid of that 250 or move it over by dividing it away, and if you do that with a calculator, you're going to find that that s-intercept I'm talking about is going to turn out to be 480. Similarly, I've got to figure out what the t-intercept is going to be. If I cover up the s, and I say, what would happen if I only sold t-shirts? Well, I'm ending up dividing the 1200 by 150, and I'll find that t-intercept is going to be 800. Now in this case, notice I haven't even yet indicated what my grid lines measure out as, but at this point I'm ready to. And it's a good thing I didn't, because if I said that was 1 and that was 2 and that was 3, then I'd have to have a huge piece of graph paper to get out to 800. So instead, I'm going to suggest that you say each tick mark is worth 200. So 200, 400, 600, 800 t-shirts, and the same for sweatshirts. Now I'm ready to plot each of those intercepts. Here's where the s-intercept goes. Roughly speaking, that's about 480. There's where the t-intercept goes. And now all that's left is to draw a line through them, and I'm done. That is the graph for this equation. Let's practice one more. Another example, a little simpler this time. Not numbers quite as big, no decimals involved. Okay, so this time I'm going to go with x and y. I no longer have to deal with s and t. I'm no longer going to have to deal with large numbers. I'll call that 1, that 2. Oops, didn't mean to do that. And I'm going to call that -1 and -2, of course. But once again, I'm going to use the cover-up method. So I'll cover up the y first. And in that case, like it shows right here, x is going to be 2. In other words, my x-intercept is 2. I can at this point go ahead and plot this one this time. And there's my x-intercept of 2. Now I cover up x, and my y-intercept, well, if I divide 2 by -2, my y is going to be -1. I plot that. Draw a line through it. It's that fast. I've now finished the task of quickly graphing, in this case, this standard form equation. Your turn. There's a standard form equation. Go ahead and graph it. Hit the pause button. When you come back, I'll show you the right answer. Okay, I'm going to assume that you did that, and there it is. The x-intercept was 4, and I've plotted an x-intercept there of 4. My y-intercept is 4/3. You probably got 8/6 and hopefully simplified it down because it's a whole lot easier to envision 4/3. Roughly speaking, that's about where 4/3 is. And I've drawn a line through it, and that is all that I had to do. Now, if you want, you can always go back and check and see, does this actually make sense, this line? And an easy way to do that is to look for a point where your line goes through the crosshairs of the grid. Now, I would say it goes through the crosshairs of the grid right there, right? Like there's a crosshair point, there's a crosshair point, there's a crosshair point. There is, but the only place where it goes through a crosshair point is either there, and it looks like it also does there. Okay, so that point right there, that's 1, 1, right? X is 1 and y is 1. I plug in 1 and 1 here. 2 times 1 is 2. 6 times 1 is 6. 2 plus 6 is 8. So it worked for this point. Let's just try one other. I said it looks like it goes through there. That point is -2, -2. -2 times 2 is -4. And this is also -2. -2 times, I'm sorry, that's +2, my bad. 2 times 6 is 12. So 12 plus that -4 we had before, sure enough, that's 8. So this line, this green line, is correct for the equation that I've come up with. And that's it. You've already probably seen on the website that that's your homework. Come in tomorrow with the homework completed and any questions you have, and we'll go over that.